Good morning, everyone. Thanks for coming. Myself, Punith. So I actually work in Shell, part of the Lubricants organization as a technology manager. And my primary focus area will be supporting the business to grow in the immersion coolants. So I've been coming to OCP for almost like 5 years now. There has been a significant traction on immersion cooling. In this presentation, I would like to talk about, as Shell, what we are doing in this space, and what do we see the challenges, and then how are we trying to address the challenges that we have. Two different technologies. I think mainly this slide presentation will be on the immersion cooling because that has been our longest journey so far. So there is a lot to cover. So we all know, due to demand for big data, there's a lot of computation happening as we speak in the industry. There is growth in the new build-outs on the data centers. And at the same time, we have certain challenges that we also address as ecosystem players. So with these demand comes the demand for or use of more of electricity for running these data centers. I think around 1% of the total electricity produced is actually going for use in the data center operations. And at the same time, because of the demand for power, there is also, because of the operations, there is more emissions happening. Around 100 metric tons of CO2 is actually released year on year for operations on the emission side. And I think traditionally, most of the data centers are build-outs with use of more of water. So we are trying to address these challenges as company, how we can, as Shell, what are the things that we could offer in this data center industry, and we are doing as we speak. So this is a slide that actually I picked up from our Shell HPC. So we have our own data centers globally, 5 of them. Main one, I think, where you can see most of the immersion activities happening in Skybox in Houston. So all these, the data centers that we are running is run by our high-performance computing team, and this is for our own needs. So basically, all the seismic work that we are doing from the upstream exploration side, flow behavior, and then data mapping, then dynamic simulation efforts for refinery activities. So all these require high-performance computing. At the same time, we are also now going through the AI revolution within the organization as well. So we are now building the computes. We have traditional data centers which are running from 2021, especially in Houston. All were based on air cooling, which the industry has been. But then lately, 2 years ago, then we switched to direct-to-chip cooling as well, because we want also to upgrade ourselves from the computation side, from the demand side, so that we do the processing. At the same time, we are also keeping an eye on sustainability aspect as well. So all this list, energy efficiency is a big thing because for running our own operations, which is like 7 megawatts of power we are using in Houston, and we are capped on the power, then the demand is high on the computation. So now we are looking at various ways how we can actually use the available power for more compute. And that's where we are actually expanding our footprint with respect to bringing in new cooling technologies. So this data center is like a museum, right? So you have a lot of floor space with air cooling, and then you have a portion of the building with DLC, and then finally the new technology that we started a year before, that is last year, August, where we started 2 megawatts of power is actually running with immersion cooling. The fluids that we manufacture is actually being used for our own needs as well. One of the challenges that we have addressed, when I go to these shows and I talk about the technologies we offer, several years back, there was one gentleman came into our booth and said, "You guys have your own data center. Have you started using immersion in your own needs?" And then we have to go back to the larger team and have these conversations with the management, and we have convinced them. So the first project that we started on immersion was in Amsterdam data center, and that is with Asperitas tank. with the natural convection. So that was our first start with this whole ecosystem, like how we can prove the technology within our own use. And then based on the learnings, now we have deployed at a very large scale in Skybox. If anyone is interested, then let me know so we can actually host and show the technology that we are actually thriving using a single-phase immersion. So this is our existing data center. I picked Skybox because that's where most of the activities is going on within us from the cooling performance standpoint. So we actually injecting a lot of cool air coming from the floor panels and going through the servers which are running in. I felt for the first time when I went inside a data center, it was like a steel mill. It was very noisy, and I could not believe that this is our own data center. So that was one of the things that we really talked about. Maybe we need to make changes here, and that's how the convincing and changing the mindset within our own organization was a very sort of like a challenging task. But we have showcased enough now and then we are bringing a lot of our customers to see the site and how we have done these changes. This is an existing data center, and we have to change a lot of plumbing, infrastructure changes. So that is something that when we deal with any brownfield data centers, these challenges will always prevail. So based on the learnings we have, we are able to actually bring in newer customers and show them what was done to get to position where we are. We can showcase the advancement. So single phase, why we are doing it? Because this is our core strength. So we manufacture gas liquid based fluids for almost like probably 15 plus years. So we have a refinery in Qatar. That's one of the biggest, largest GTL gas liquid based refinery that is based there. So we manufacture different products, including used for finished lubricants and many other applications. As Shell, so we have a lot of needs for our own lubricants organization. So we manufacture, we bring it to our different, the distribution points. And we have a production unit based in Houston, so we serve the North America region. In the past, when we started, it was all in Europe. We learned a lot, and we realized that most of the, all the biggest OEMs are all in the West Coast area, so we realized that this is the market. We need to come in and then actually support the needs from the supply chain standpoint. So why we believe this is a value addition to the industry is because we have demonstrated within our own data center, you can reduce the energy consumption by 30%, and you can showcase that 30% of savings that we get from the power, actually use it for maybe doing more compute. Because we are capped on power, so we are trying to improvise how we can actually lower the PUE values for the existing data center, and I will show you some slides which talks about it. So this is our journey. So as I said before, this is for Skybox. This is one data center. So in 2019, where we started with air cooling, we still have a portion of the building with air cooling. And our PUEs are around maybe 1.6 to 2.5. But 2.5 is a high side because one of the data centers we have in Asia Pacific, which is really bad with respect to energy efficiency. But because we represent HPC for Shell, so we know the ranges that we deal with when you're actually going for air cooling. 2021, we actually started with direct-to-chip cooling. We brought down the PUE from 1.6 to 1.2. That's also a representation that how much changes we can bring in your own needs. And one of the highlights there is that 30 kilowatts per rack was probably the limitation that we had with air cooling. We scaled it to, doubled it to close to 70 kilowatts with Cool ID systems that we have, which are running with DLC there. Then the need was so high for the HPC data center is, how can we improvise this more per rack? So now we have deployments with 100 kilowatts per rack or beyond. With the help of GRC, we are actually, demonstrated to the industry that you can actually scale more than 100 kilowatts. And our fluids actually running perfectly fine. And we have gathered a lot of information about the fluid characteristics along the way because everybody wants to see the real-time data. Because new fluids, everything looks good, but people want to know what happens 3 years down the line, 5 years down the line. So we are also gathering that set of reliable information so that we can actually share it with customers as well. And the last part is on the immersion, as I said. So now we are actually close to less than 1.1 on the PUE. The range is 1.03 is probably the goalpost that everyone wants to achieve. Because this is an existing data center, so you have cooling infrastructure I cannot change outside the building. So I have to stick with what we have with respect to chillers and evaporators that we are running with. So with the given system, by just changing the cooling technologies, how much I can bring changes. I think this is a living example, and we can actually showcase if somebody is interested to come over. So we use this fluid, S3X. And this is the single phase. This is our breadwinner. People have used, and we have actually sold millions of liters in the market. And we have got excellent reviews. And we will stick with this for now. We are actually going to deploy our own data center in Bangalore. We are creating an AI cluster where we'll be deploying with H100 GPUs as well. So we have gone through AMD 4th generation chips, Intel CPUs. Now we are actually deploying that will be in the production workload environment. It's not a science project because data centers, when we go in, they have to just hook the systems in, start running the algorithms. So by end of this year, you will see some announcement being made that they will be using S3X Fluid for H100's deployment. So these are the journey that I talked about. We started from Netherlands, then Houston. We are now bringing immersion technology into Bangalore. So there is a lot of demand. So AI is making us to go into higher TDP regions as well. 700 watts we are talking, but probably in the near future we will be going higher, probably 1200 watts. So we are demonstrating not just for ourselves, but even for NVIDIA as well, because they would like to see the reliable data, how this results is going to come out based on the immersion activity, because they need information from the real time, that is in the production environment, not in a lab, not in some corner of the building, from the real data center. So they have been involved from the beginning for this cluster that we are creating, and we have already passed all the NV qual requirements from the signal integrity. That has been a biggest concern when we are actually dunking in with fluids, especially for single phase. So you will hear more when by end of this year on the AI deployment. As technology organization which I represent, we do support to customers. There are a lot of things because it's an evolution we are going through. A lot of challenges because there are thousands of components being actually immersed, and people would like to see how is the chemistry making a difference when they are actually going with the bill of materials. So we actually have worked with extensively with the chip manufacturers, all the major ones, and we have run all the bill of materials that goes in the servers, so that making sure that what is working, what is not working, so that they have a full view, so that when they're actually going with the customers, they know that some of the materials that did not go well with this chemistry, so then they actually can give an intimation to the OEMs, such as the tank manufacturers, so they can actually change the components and make sure that it is being immersed. So this is in public news. So we are actually, as I said, collaboration is necessary. We need everybody in the market, especially the ecosystem players, the chip guys, the server guys, and the tank manufacturers, and also the end users. So some of the announcements where we are actually bringing the whole ecosystem together to see that we can actually breach the 1,000 watts TDP levels and beyond, because that's where the industry is headed, and we have to work with the ecosystem so that everybody is feeling comfortable with this chemistry that we talk about, and then so that we can go to market quite easily. So this is one of the slides I just want to just touch base on. We are getting into direct-to-chip cooling technology. We will be manufacturing water-based coolants as well, because we all understand that ecosystem is going on at scale. All the big ones like Meta, Google, Microsoft, they're going into DLC for time being. And we want to actually serve this market because we believe that we have one of the best chemistries, because coolants is a big division for Shell, and we can bring the know-how for the electronics cooling as well, and then entering this market probably early next year, so that the same OEM has the experience working on the DLC as well as on the immersion, so that Shell can offer different products for the customers, so that they can, wherever they make the decision, whether it is DLC or immersion, we are able to offer them the solutions. That's it from my side. If you have any questions, so I'll be at C4 in our booth, so I can answer any questions if you have on the Shell technology. Thank you.